Hi everyone, in this video we are going to discuss about how to calculate the coordinates of the reflected point when a point is reflected on y-axis, right? So for example, let's suppose we have a point P which is located in the first quadrant and its coordinates are x, y, and then let's assume that the reflected point, which is noted here as P prime with coordinates of x sub 1, y sub 1. So we have to find out what would be the coordinates of P prime when the coordinates of P have been provided. Let's assume that the coordinates of P have been provided, which are x and y. Let's assume that the values of x and y have been provided, and now we have to calculate the values of x sub 1 and y sub 1. Now, since it is a reflection, you can assume that the y-axis is like a mirror. Now we are taking a reflection on the y-axis. So if y-axis is the mirror, from the theory of reflection of light in physics, we know that the distance of the object from mirror and the distance of the image from mirror, those two distances are equal. Now let's assume that this point on the mirror right here, the point on the mirror, I have a pink dot right there, and let's assume that that point is A. Suppose that point is A. Now what would be the coordinates of A? Well, if you think about it, A is actually on y-axis, so the x coordinate would definitely be 0. And what would be the y coordinate of A? Well, the y coordinate will be same as the y coordinate of P. Now we know that the y coordinate of P is y, which has been provided, that's the assumption. So then the y coordinate of A will also be y. That would be the y coordinate of A, and x coordinate obviously 0, right? Now if you think about the line segment P prime and the length of AP and AP prime, they are equal because the object and the image, they are always at the same distance from the mirror. So in this case, can we write it like this? Essentially, AP is the distance of the object from mirror and AP prime is the distance of the image from mirror. So those two distances would be equal, and if that is the case, you see that A is in the middle of the line segment because the distance of P from A and the distance of P prime from A, those two distances are equal. That means A is in the middle of the line segment, and if that is the case, we can assume that A is the midpoint, and if A is the midpoint, then we should be able to use the midpoint formula. I have already created a separate video on that. I will provide the link in the description. Feel free to watch that video. But from the midpoint formula, we know that the x coordinate and y coordinate of the midpoint can be written like this. So what is this x? Well, x is the x coordinate of the midpoint. And what are x sub 1 and x sub 2? Well, those are the x coordinates of the two extreme points, right? We are talking about a midpoint and the two extreme points. So x sub 1 and x sub 2, they are the x coordinates of the extreme points, and x is the x coordinate of the midpoint. So now from here, can we say like this? Let's now focus on just the x coordinate here. So now, because x is the x coordinate of the midpoint, now what is the midpoint in our case? In our case, the midpoint is A, and what is the x coordinate of A? That is 0. So can we write it like this? So 0 is equal to, now let's suppose x sub 1 is the x coordinate of P prime. So I am keeping that as x sub 1 because that's exactly what I have assumed as the x coordinate of P prime. And then plus x sub 2, let's assume that x sub 2 is the x coordinate of the other extreme point, which is the original point P. Now what is the x coordinate of point P? Well, we have assumed that to be x. So I am keeping it like that, and then whole divided by 2. So from here, can we say it like this? If we multiply both sides by 2, so it would be 0 is equal to x sub 1 plus x. And from here, can we say that x sub 1 is equal to negative x? So we have found the value of the x coordinate of the reflected point, which is the image in this case, right? The P prime. So we have found the x coordinate of P prime. Now let's also calculate the y coordinate. Now if we take the y formula, so let me first write down the y formula here, which is kind of like this. And now what is y? Well, y is the y coordinate of the midpoint. Now in our example, what is the y coordinate of the midpoint? Well, we have taken it as y. It's actually y, right? So I'm keeping it as y. So y is equal to, then what is y sub 1? Let's take y sub 1 as the y coordinate of P prime. So I'm keeping that as y sub 1 plus what is y sub 2? Well, let's take that as the y coordinate of the other extreme point, which is the point P, and whose y coordinate is actually y, and whole divided by 2. And from here, what do we get? Well, from here, if we multiply both sides by 2, we get 2 times y is equal to y sub 1 plus y. And from here, can we say it like this? Well, then y sub 1 is equal to 2 times y minus y, which will be equal to y. So that is the y coordinate, that is the y coordinate of our reflected point. So we have calculated both the x coordinate and the y coordinate of the reflected point. So here let's make a quick note here. So if the original point is P, whose coordinates have been provided as x comma y, then the coordinates of its reflection, I'm just writing it like this, the coordinates of its reflection on y axis, let's assume that there's the P prime and its coordinates would be negative x comma y, right? Because those are the two values we have calculated. So when we take the reflection of a point on y-axis, actually what happens, the sign of the x coordinate of original point is changed when we use it in the reflected point. That means the x coordinate of the reflected point will be the opposite sign of the x coordinate of the original point. That means you can pretty much use the value of x and y. All you have to do is just change the sign of x or change the sign of the x coordinate, right? So let me make a note right here that when you are trying to figure out the coordinates of the reflection, all you have to do is just change the sign of the x coordinate of the original point, right? So let me make a note right here. Now let's take an example. Suppose we have an example like this. Suppose we have been given a point P whose location is, say, suppose 2, 3. And then we have been asked to find out what would be the coordinates of its reflection. Suppose the reflected point is P prime, or the image of this original point is P prime. We have to find the x coordinate of that point and the y coordinate of that point. Now how would we do? It's very easy. All you have to do is, if we are taking the reflection on the y-axis, then we know exactly what to do, right? So this example is for reflection on the y-axis. Now here you can see that all we have to do, we just have to change the sign of the x coordinate. The y coordinate can be used as is. So we can say that the x coordinate of the image, which is P prime, would be the opposite sign of the x coordinate of our original point. Now what is the x coordinate of our original point? That's positive 2. So here we can simply say that this is going to be negative 2. We just have to flip the sign. You just simply change the sign and use the same value just by changing the sign. And then what would be the y coordinate? As you can see, when we derived the coordinates of P prime, we see that the y coordinate of P prime is exactly same as the y coordinate of the original point P. So in this case, in this example, we can also use the same value, which is 3. So 3 is also going to be the y coordinate of the image P prime, right? So if we take the reflection of point P on y-axis, then the coordinates of its image would be negative 2, 3. Let's take another example. Suppose this time our original point is located maybe somewhere in the third quadrant. Let's say suppose negative 2, negative 3. Right, that would be a third quadrant point, and we have to find out the coordinates of its image when reflected on the y-axis. So let's assume that the image of this point is P prime. Let's just assume, right? And now we are going to calculate the coordinates of this image. Now what is our policy? Well, our policy here is that if the reflection is happening on y-axis, then the y coordinate would remain same. So the y coordinate can be written as negative 3. Whatever was the negative 3 right here, I'm just simply writing that same value right here as the y coordinate. And then what would be the x coordinate? Well, for x coordinate, we have to flip the sign. So for the x coordinate, all we have to do is flip the sign. Now what is the x coordinate of the original point? Well, it's negative 2, which is right here. Let me underline this. So the negative 2 right here, I'm going to flip the sign and I'm going to write it as positive 2. So now you see the coordinates of the reflected point P prime would be 2, negative 3. I hope everything made sense so far. Thank you for watching. See you in the next video.